Have you ever wondered about the importance of those massive ice formations we call glaciers to our planet? These frozen giants are much more than just breathtaking landscapes. They're integral parts of our world's ecosystem and climate system. Imagine, if you will, a time-lapse spanning thousands of years. Watch as countless snowflakes fall, one on top of another, compacting and compressing over millennia to form these magnificent structures. Each layer, each particle of ice, tells a tale of our planet's history, locked away in a frigid time capsule. Their sheer size alone is awe-inspiring, but their true value lies beneath the surface. They are the world's largest freshwater reservoirs, supplying us with a precious resource. They serve as climate regulators, reflecting sunlight away from Earth, helping to maintain our planet's temperature. These frosty giants, therefore, are not just scenic wonders, but hold a much deeper significance. So, how do these remarkable ice structures form, and are they all the same? Well, let's start with their formation. It all begins with the accumulation of snow. Over time, as more and more snow falls and piles up, the weight of the snow compresses the layers below. This pressure gradually turns the snow into a dense, grainy ice called firn. As the process continues, the firn gets compacted further and eventually transforms into what we commonly know as glacier ice, a dense, crystalline structure that's so blue because it absorbs all other colors of the spectrum except blue. But not all glaciers are the same. They can be broadly classified into three types: alpine, valley, and continental glaciers, each unique in its own way. First, let's talk about alpine glaciers. These are found in mountain ranges and are shaped by the terrain they flow through. As the name suggests, they are high-altitude glaciers and are often the source of our picturesque snow-capped peaks. Next up are valley glaciers. These are essentially alpine glaciers that have carved out large valleys over thousands of years. They snake their way down from mountaintops, following the path of existing valleys. They're like rivers of ice, flowing from high to low ground. Finally, we have the continental glaciers, the big daddies of the glacier world. Also known as ice sheets, these are massive ice structures that cover more than 50,000 square kilometers. There are only two of these on Earth today, blanketing most of Antarctica and Greenland. These glaciers are so massive that they essentially create their own terrain, rather than being shaped by it. Each of these glacier types has a unique formation process, influenced by factors like location, climate, and topography. They might all be made of ice, but their characteristics and behavior make them distinct from one another. From the towering alpine glaciers to the sprawling continental ones, each has its unique characteristics and formation process. But beyond their grandeur and beauty, why should we care about glaciers? Well, glaciers are much more than just frozen bodies of water. They are nature's timekeepers, storing information about past climates and environments. They are the world's largest freshwater reservoirs, holding about 75% of our planet's fresh water. This can become a vital resource in the future, especially considering the increasing threat of water scarcity. Glaciers also play a crucial role in regulating sea levels. When they melt, the water doesn't just disappear. It flows into the seas and oceans, contributing to rising sea levels. Imagine, if all the glaciers were to melt, sea levels would rise by a staggering 50 feet, submerging coastal cities worldwide. But their influence extends beyond just sea levels. Glaciers also affect weather patterns and climate. Large glaciers, like those in Antarctica and Greenland, reflect sunlight back into space, helping to cool our planet. However, as these glaciers shrink, less sunlight is reflected, and more is absorbed by the ocean, causing further warming and leading to a vicious cycle of melting. Perhaps most importantly, glaciers act as a clear indicator of climate change. Their retreat is a visible sign of global warming. Scientists can measure the rate at which glaciers are receding to gauge the pace of global warming. This is crucial for making accurate predictions and formulating effective strategies to combat climate change. And yet, despite their importance, glaciers around the globe are in retreat. This loss is not just a loss of a natural wonder. It's a loss of a vital ecosystem, a loss of a crucial climate regulator, and a loss of a potential life-saving water source. The fate of these icy giants is intertwined with the health of our planet, and their decline should concern us all. As we move forward, let's remember that it's not just about saving the glaciers, but also about preserving our world, Let's not wait until it's too late. Let's act now, for the sake of glaciers, and for the sake of our future. The fate of these icy giants is intertwined with the health of our planet, and their decline should concern us all. In our journey today, we have discovered the fascinating world of glaciers. We've seen how they form, understood their various types, and unraveled their profound importance to our planet. These are not just frozen rivers, but natural archives recording Earth's climatic history. They are our water reservoirs, our sea level modulators, and our climate regulators. Remember, these frosty giants are not just scenic wonders, but hold a much deeper significance. The health of our planet is reflected in the state of our glaciers.